Okay. Before we get started with the lecture, there was a few students who did not put their student number on the quiz. It was like 3 or 4 students. So on Student Central, it will come up as AB because I can't capture your mark. Okay. Mark capturing is with student numbers only. You don't give me your student number, there's nothing I can do with your quiz. Same thing for last week. There were about 3 or 4 of you who didn't put your student number. So that's just going to stay AB. After a week, the ABs automatically get changed to zeros. After that, I can't do anything for you. Okay, so those students with ABs that did the quiz, you have until next week, Tuesday, to fix that. Otherwise, that gets turned into a 0. Okay, so please double check that and then fix that as soon as possible. Okay, so today we're going through a new chapter on conic sections. So that will be the ellipse, parabola, and hyperbola. So we'll go through all of the constructions today, which is what you're going to be needing for the group project next week. Okay, I hope you all have your groups ready for that. Then on Thursday, during the double, we will go through all of the examples that will then be on the quiz and test and so on. Okay, so today we'll go through everything you need for the project. Thursday, we'll go through everything you need for the tests. Okay, so let's get started. Okay, so the conic sections are broken up into 3 categories. So each of them, you should know what they are. But what we're going to do is group them into one nice set called conic sections. And we're going to see how they are related to each other. So the first conic section is the ellipse. Okay, so you should be familiar with the general idea of an ellipse or oval. You might have heard of that. This is given by x squared over a squared plus y squared over b squared is equal to 1. Okay, so that's the general equation for that. And we're going to see how we get all of these equations today. Okay, next is the parabola. Okay, so you're all familiar with that. Under the section for conic sections, it has a slightly different formula, so we'll see how we get that. But we write it as y squared equals 4 times p times x, so we'll see where this p comes from. But that's the general form for a parabola if we consider it as a conic section. Okay, and we can also write it as x squared equals 4 times p times y. Okay, so these 2 equations will correspond to a parabola going vertical or a parabola going horizontal. Okay, we'll cover that in a bit. Okay, and lastly, the hyperbola. Okay, so you're familiar with the 1 over x hyperbola, okay, the rectangular hyperbola. We're going to be looking at a more general group of hyperbolae. So that will be given by x squared over a squared minus y squared over b squared equals 1. Okay, so very, very similar to the ellipse. So the ellipse has a plus there, hyperbola that will have a minus. And if we swap the order of these, we get a hyperbola that is horizontal or a hyperbola that is vertical. Okay, we'll see that later. So again, if we swap the order and we have y squared over b squared minus x squared over a squared equals 1, that just swaps the orientation. So either it's going to be horizontal or it will be vertical. Okay, depending on which one you choose. Okay, so a little bit of background on why we call it a conic section. So everyone's familiar with what a cross section is. If I give you a shape, you can cut it, and then that will give you a cross section. A conic section is a cross section of a cone. Okay, so just keep that in mind. So let's say we have a cone like this. It's a double-ended cone, so it's like 2 ice cream cones together. So we have a cone like this, and we're going to look at 3 types of cross-sections. These 3 types of cross-sections will then give us the conic sections. Okay, the first one is if we cut this cone at an angle. So just imagine we've got this double-ended cone, we're going to cut it at an angle, and we look at the cross-section of it. So it will be something like this. Okay, so it's a plane. We cut it at an angle. The cross-section will then be something like that. Okay, so I hope you can imagine that in your head. You've got a cone. You cut it. You look at the cross-section. That shape there, that is an ellipse. Okay, so that is how we get an ellipse. You take a cone, you find the cross-section by cutting it at some angle, and you see there in pink, that is the cross-section. That will be an ellipse. Next, a parabola. Very similar to this. Again, we've got our double-ended cone. Okay. Now, instead of cutting it like this, we cut it at a very steep angle. So it's going to be something like this. Okay, so again, we cut it at a very steep angle, and the cross-section here, like that, that will be a parabola. Okay, so again, you got your cone, you cut it almost vertically, not quite, so a little bit off vertical, but a very steep cut. The cross-section that's produced there, so this is like a, you got your, was it hatching or whatever you call it. You cut it, that shape there is a parabola. Okay. And finally, if we make this angle all the way to 90 degrees and then cut it, we end up with a hyperbola. Okay, so again, the angle is getting steeper and steeper. Finally, we cut it vertically. So it's something like this. And we see this shape will then be a hyperbola. Okay, so you cut it vertically, and then that cross-section that you see at the top and the bottom, that's going to be a hyperbola. Okay, so this is why we call these three conic sections. So you take a cone, find the cross-section, and then you get conic section. Okay, so that's where it comes from. All right. So let's see how we define these geometrically. So in the Cartesian plane, we're going to have definitions for these three. So again, this just gives you the shape. You can't do much calculations with this. So next we're going to look at how they're defined in the plane. And then that will give us these three equations over here. Okay. And then those planar definitions, so how you define it in a plane, is what you're going to be using in the group project to draw these. Okay, so number one, the ellipse. So how do we define the ellipse in the xy plane? So let's draw in our Cartesian system here. So we've got x and y. We're going to have some shape that we're going to call the ellipse. Something like that. Very rough sketch. Okay, so how do we define this shape? Well, we're going to pick two special points along the x-axis. Those are going to be called the focal points. So on this left side, we have a focal point F1. This is given by the coordinates minus C0. Okay, so on the left side, we have focal point number 1. And on the right side, we have focal point number 2. That is given by C0. So on the left, minus C. On the right, plus C. Okay. Next, a point on the ellipse, let's call that P, is given by Pxy. Okay, so again, along the x-axis, we choose two special points, F1 and F2. Those are called the focal points. Then point P, that will be on the ellipse. Okay, so how do we define this? We're going to draw a line from F1 to P. Okay, then we're going to draw a line from P down to F2. Like that, straight line. Yeah, so we've got a line, F1 to P, and then P down to F2. Okay, and then I did say this, but I'll write it out, F1 and F2. are called the focal points. Right, just some terminology for all of these points here. Okay, so given this construction, how do we define the ellipse? So we define the ellipse as the set of points P, X, Y. Okay, so all those points P that go around, so that's our graph of this. So the set of points P, such that the distance F1P, right? So from F1 to P, we call that distance F1P, plus F2P. Okay, so from F2 to P, that's the distance there, is a constant. Okay, some constant. So you change the constant, you change the size of the ellipse. Okay, so again, F1 to P, that length, plus this length over here, you add those two together, that must be fixed, some constant. So just an aside for your group project, what you're going to do, you have a group of 3, so it's going to be one person and some helpers, okay, for each one. So F1 and F2, that will be fixed, okay, depending on the problem, that will be given to you. Okay, so that's going to be fixed. Now, the distance from F1 to P and P to F2, that is also fixed. That length is fixed. Okay, that will be given to you. It'll be like 16 centimeters or something like that. So what you do is you take a piece of string that is 16 centimeters long. One end you fix at F1. The other end you fix at F2. Not many people are writing this down. I hope you're going to be able to do the project. Okay. So you end up with the string from F1 to P down to F2. That total length of string is fixed, which means the length of F1 to P and P to F2 is also fixed. Okay, so you put your pen or pencil at P and you try to draw a circle going around. And in doing so, with those lengths being fixed, it ends up being an ellipse. All right. So yeah, no. The F1 to P plus P to F2, that is fixed. The individual lengths are not fixed.
From F1 to P, F1 to P and F2,
those lengths are different, but the sum is fixed. The sum is fixed, yes. Yeah. We'll write it down explicitly now. But the idea to make the sum fixed is to use the string. So the string has fixed length. So F1 to P, P to F2, that total length is fixed. Okay. Then you draw your loop around, and that will give you an ellipse. Right. Any questions for that construction? Okay. I'm not answering any questions on the day. Group projects, I leave you to do it, and then I'll take your papers at the end. Okay, you can't be asking questions on the day. Are there any questions for this? No questions. Okay, we'll move on. Okay, so given this constraint here, F1 to P plus P to F2, that is fixed. What we want to do is start with that and end up with this. We're going to end up with that over here. Okay, so that's the idea. And we're going to do the same for the other two. Okay, so let's write out the constraint. So it was the distance F1 to P plus the distance F2 to P. This is equal to a constant. So we're going to say this is equal to 2 times A. Okay. The 2 is just to make the equation look nice. You can call it A if you want, okay? But if we call it 2A, it helps neaten things up at the end. Okay, but altogether, this is a constant. Okay. Now, from here, we just use the distance formula. So the distance from F1 to P, we use the distance formula. F2 to P, we use the distance formula. And then the rest is just algebra. So for this one and the parabola, I will do all of the algebra for you so you can see how to do it. The third one, that will be for homework. Yeah. So if you understand it from the first two, the third one, that's easy. Okay, so a distance formula. So we have the root of x plus c squared plus y squared plus the root x minus c squared plus y squared is equal to 2a. That's just the distance formula, nothing special there. Okay, so from this step onwards is just algebra. Okay, so let's go through it. So we're going to keep one of the roots on this side. So x plus c squared plus y squared is equal to 2a minus the root x minus c squared plus y squared. Okay, we're going to take it over to the other side, and I'm sure you can guess what's next. We square both sides. Okay, so we're going to have x plus c squared plus y squared is equal to, and we're going to square this side. Yeah. Let's expand out a bit. So x plus c squared. Someone had a question? No. Okay. X plus c squared, that will be x squared plus 2xc plus c squared plus y squared. And then on the other side, let's expand that. So we're going to have 2a squared, so that's 4a squared altogether, minus 4a times this root. Okay, plus the root squared, but that's just the stuff inside. Okay, so we end up with this. Now some stuff cancels. Look on the left side and the right side. We got y squared there, y squared on the other side, so that can go. Okay. Then some more stuff can go, because we've got x minus c all squared on the right there. If we expand that out, that will cancel with some stuff on this left-hand side. So let's do that. So we've got x squared plus 2xc plus c squared is equal to 4a squared minus 4a root x minus c squared plus y squared plus, okay, and then expanding that out. So that will be x squared minus 2xc plus c squared. Okay, so a bit more cancels. Left-hand side, we have an x squared. Right-hand side, we also have an x squared, so that can go. Left-hand side, we've got c squared. Right-hand side, we also have c squared, so that can go. So we end up with this. Okay, now we've got 2xc on the left-hand side. We've got a minus 2xc on the right. Let's take that over. Okay, so we just take it over to the one side. And then what's left over from all the cancelling, that will be 4a squared minus 4a roots x minus c squared plus y squared. Okay, so we end up with that. Okay, so we've got this root again. So we're going to have to do another squaring on both sides to get rid of that. So let's take the 4a squared over, and then we can square both sides again. So we're going to have 4xc, adding those two together, minus 4a squared is equal to minus 4a root x minus c squared plus y squared. Okay, so we have something like that. Let's leave the 4a on that side. We don't want to work with any fractions just yet. So let's just square both sides as is, and that will get rid of the roots. So we're going to have 4 times x times c minus 4a squared. Squared again, because we want to get rid of that root. Okay, and then on the other side, squaring that, the minus, don't worry about that, that goes away. It will be 16a squared, and then whatever's inside the root. Again, all of this is just algebra. There's nothing to worry about. let's expand that left-hand side, and then we'll take a look at the right-hand side, and more stuff will cancel. Okay, so this side, we've got 16x squared c squared minus, what do we got there? 32. Xca squared plus 16a to the 4. Okay, from that. On the other side, let's see what we get. So we have 16a squared. Then x minus c squared. Let's see what we get there. So it will be x squared minus 2x times c plus c squared. And then we still have that y squared there. Okay. So we here. Now we got the factors of 16 throughout, so we can cancel those. So we have x squared c squared minus 2x times c times a squared plus a to the 4 is equal to, we just cancel the 16 there. So that will be a squared x squared minus 2x times c times a squared plus a squared c squared plus a squared y squared. Okay, we end up with that. Okay, let's see if anything else cancels. Left-hand side, minus 2x times c times a squared. Right-hand side, close to the end there, minus 2 times x times c times a squared. That can go. So there and there. Anything else? No. Okay, so you can leave it like that. Okay, so let's take everything over to one side, and then we'll try and simplify as much as possible. Okay, so we're going to have a squared x squared. We're going to leave that over there. Okay, from that right-hand side, we're going to leave it. Okay, minus c squared x squared. Okay, from there. Plus a squared y squared. That's that last term on the right side there. Okay, so all of the xy's we leave on one side. Yes?
So the a squared is on the right.
Yes. No, I'm putting it on that side. You just put it on the other side. So that a squared x squared, we leave it there. And then what happens when we take the x squared c squared over? You get the minus. Okay. You can put the in-between steps if you need, but I'm assuming you can do your algebra between steps. Okay, then all of the constants we leave on the other side. Okay, so x squared, y squared, we leave it on one side. All the other stuff we take over. So that's going to be the a to the 4 minus a squared c squared. So that's the remaining constants. Okay, now we can do some factoring. First two terms, we can factor out the x squared. So it's going to be a squared minus c squared times x squared plus a squared y squared. And on the other side, we can also do a little bit of factoring, a squared and a squared. So we can take out an a squared, and we leave with a squared minus c squared. Okay, so that's after all of the factoring. Finally, we're going to divide everything by that constant on the right-hand side. So we're left with x squared over a squared, because the a squared minus c squared, that will cancel, plus y squared over a squared minus c squared, because the a squareds cancel, and right at the end, that's just going to be 1. Okay, and finally, to make it look a little bit nicer, we're going to define b squared to be that denominator, a squared minus c squared. Please put a big box around that. That will be very important. Okay, so this b squared that we're introducing will be a squared minus c squared. Okay, please don't just write b and not know where it comes from. Okay, and if we do that, then we're going to have y squared over b squared. So we end up with x squared over a squared plus y squared over b squared is 1. And then please put another box around that. Okay. And after all of that algebra, we get the ellipse equation. Yeah. Yeah, a lot of algebra. Yes, I agree. Yes. Second to last step, this one. Yeah, so left-hand side and right-hand side, we divided through by this. So look on the right-hand side, we've got a squared minus c squared. I'm going to take it over. So a squared minus c squared divided by a squared minus c squared cancels. Right? Then we divide by a squared, so that's left over. Yeah, so it's something like this. So a squared minus c squared x squared over a squared minus c squared. And then that will cancel. We're left with that bit. Okay. Similar thing for the y. You end up with something like that. Okay. Again, please put a box around this b squared, where we got that from, and then a box around the final answer. Right. Any other questions for the algebra stuff? Okay. I assume you can do the grouping and the squaring both sides, all of that. Okay, I assume you already know that stuff. Okay. And then finally, just a little summary of all the important points. Yeah. So just some terminology and stuff that we use. So let's say we've got our ellipse like this. So F1, F2, remember that from the beginning. So F1 and F2, those are called the focal points. Okay. Then we have two other points. So these endpoints here of the ellipse, so on the extreme left and the extreme right, we call that V1 and V2. Those are called the vertices. Right, it's just the names that we give to these points. Are called the vertices. And given this ellipse equation like this, we can find the vertices like so. So V1, if you call that the left one, that will be at minus A0, right? Where A is this A from here. So that will be at minus A0. So that's the left one. And then V2, if you call that the right one, that will be A0. So that's the plus one. Okay, so those are the vertices. Okay. And then the focal points, we said that earlier, that was F1 was minus C0, and F2, that was C0. Okay. That's the same C from here, right? Okay. Okay, some more terminology. The longer length here. Okay, so your ellipse could be stretched horizontally or vertically. Okay, whatever the longer one is, in this case it's horizontal, we call that the major axis. Right, that's the longer one. And then the other one, that's the shorter one, we call that the minor axis. Okay, so here it's stretched horizontally, so that's the longer one. That will be the major axis. And then vertically, that is the minor axis. Okay. And then one last thing, depending on where you look, these vertices at the top and at the bottom, sometimes they're included, sometimes they're not. But those are the minor vertices. So the vertices along the major axis, those are the vertices or the major vertices. And then the other ones, those are sometimes called the minor vertices. So that will be at 0, B, and at 0, minus B. So those are the minor vertices. Fine. Yes?
Just wanted to check if the DML is yours or
No, this is my one. We have to provide our own.
thank you.
Sure. Okay. So again, that just depends on where you're looking. So in the Stewart textbook, I don't think it includes that. But if you look at that other one, the one by Paul, I think that is included. Okay, so again, depends on where you're looking. But again, you've got your major axis with the major vertices, minor axis, minor vertices. Otherwise, it's just called vertices. Okay. Any questions on the naming for these things? Oh, good. Okay, so that is the ellipse. Let's have a look at the parabola. Okay. So again, we're going to have a very similar definition to the ellipse. And then from that definition, we do a whole lot of algebra like we did before. And we will end up with one of these. Okay. So let's have a look at how this is defined. So we have our xy axes as before. Then we've got our parabola, like so. Okay. So the way we define the parabola is by providing a fixed point somewhere there. That is called the focal point. Right. So the ellipse that has two focal points, the parabola that has one focal point. And here we call it F0P. Okay, so that is our focal point. That will be given. So we choose the focal point, and then from that, we can then fill in the rest of the parabola. Okay, next, we have a line underneath here. This is given by y equals minus p. So the same p we used for the focal point is the p we use for the line at the bottom. Okay, this is called the directrix. Okay, or the directrix line. Okay, so that is the line underneath the parabola. And again, the distance from that origin point to the focal point, that will be p, because it's at 0p. And then from that bottom point down to the directrix line, that is also p. It's the same p used for both. Okay, so given those two, we can then define our parabola. So for any point p, let's say pxy on the parabola, we're going to draw this line over there. And we're going to draw a line going down to the directrix. Okay, and it must be at 90 degrees. So that's a vertical line over there. Okay, so the definition for the parabola is very simple. So once you've done all of this construction, FP line from there to there, this line is equal to this line. And that's it. That's the definition. Okay. So you put your focal point, F, you put your directrix line, y equals minus p. Then any points on the parabola, from that point to the focal point, that distance is the same as the distance from that point to the directrix. So those two have the same distance. That's how we define the parabola. Okay, so let's write it out. So we define the parabola as the set of points P. Okay, such that. Okay, and then it's what I just said there. So the distance from F to P. So such that the distance F to P is equal to the distance. Okay, that's the vertical distance, just to emphasize that. The distance from P to that directrix line at the bottom. Okay, and that was y equals minus p. Okay, so that is the definition in words, so that's how we define it. So let's write out an equation for this. So again, distance formula, a whole lot of algebra, and then we get that equation we had at the beginning. Okay, so firstly, what is this distance fp? So we know f, that's given here at 0p, and we know p, that is just xy. So that's given. So ft, just distance formula. So that will be the root x squared plus y minus p squared. Okay, again, that's just distance formula. Okay, so what does this mean? The distance fp is equal to the vertical distance from p to the directrix line. Let's write that out. So that will be fp must be equal to the vertical distance. So what will that be? So from p down to the x-axis, what is that distance? Y. Yeah. And then from the x-axis down to this line, what is that distance? What's the distance? From this line to this line, what is the distance? How can it be minus p? You're giving me a negative distance. What is the distance? P. Yes, p. Thank you. If you're telling me the distance is minus 2, there's some problems. Okay, it's p. The distance is p. So the top part was y, the bottom part was p, so the total distance is y plus p. Yeah, it's just the sum of the two. Next, fp, we know what that is, just distance formula that we had there. So this is going to be the root x squared plus y minus p squared is equal to y plus p. Okay, same stuff as before. We want to simplify this. We've got this root, so we square both sides. So we're going to have x squared plus y minus p squared is equal to y squared plus 2yp plus p squared. Okay, we can expand out the other square from that left-hand side. So we have x squared plus y squared minus 2yp plus p squared equals y squared plus 2yp plus p squared. Okay, so everything expanded out. Let's see what cancels. We've got y squared on the left and the right. That can go. We've got p squared on the left and the right. That can go. Next, we've got minus 2yp on the one side and 2yp on the other. We can just take it over to the other side. And we end up with x squared is equal to 4yp. Okay, not so bad. Okay, few lines of working, maybe test type question. That first one with the ellipse, no ways. You're going to be there for days trying to do all the algebra. This one, maybe. It's not so bad. Okay, so that ellipse one, please do not memorize that. You're wasting your time. I'm not going to ask you to do a whole page of algebra for nothing. This one, that's not too bad. Okay. So just make a little note. So when you're studying for the exam, you can leave the one thing out and keep the other thing. Okay, so we end up with this. Now, this is for a vertically oriented parabola, like this one. It goes up or down. We can swap x and y, and then it will be facing left or right. Okay, so we can get a very similar equation just by swapping x and y. Okay, well, we won't go through that. That is on the first page, where I put the two equations. Okay, next, just a summary. So again, you know, the focal point, vertex, all that stuff. So for a parabola, we have the equation x squared equals 4py. Okay, so you should be familiar with that equation. Then the focus, we had that right at the beginning. That was at 0p. Let's call that f. That was at 0p. Then the vertex. You can think of the vertex as like a turning point. So if we go back to this ellipse here, we see on this side, you can think of it like a turning point, and on that right side, it's like a turning point. Here, same thing, but there's only one turning point at the bottom. So here, the vertex is just given by 0, 0. Right, very easy to remember. And lastly, the directrix. That was y equals minus p. Okay, so as long as you remember this little summary, then you can find these points quite easily. Okay, and then just a quick note on the orientation. Okay, so like I said earlier, you can have the vertical ones and the horizontal ones. So we end up with 4 cases. So it could be facing up, facing down, facing left, facing right. So we'll just do a quick summary of all the orientations. So the first one, facing up, will look something like this. So it's going to be facing up, and the directrix line will be underneath, like what we had earlier. Let's put that in blue. So that is case 1. This is when p is greater than 0. So if p is greater than 0 and it's vertical, like this, then it will be facing up like that. Then if it is facing down, we're going to have it like that, sad face parabola, and then the directrix will then be at the top. Okay, so we'll have something like that. And in that case, p is less than 0. Okay, so it's a little bit swapped. So if p is greater than 0, the line is underneath. And if p is less than 0, the line is above. Okay, I didn't invent this, don't blame me, but that's just how it is. Okay, so please, in your minds, just swap it. So p being positive, the line is under. P being negative, the line is above. Okay, you're just going to have to deal with that. Okay, so that is up and down. Then we have left and right. So left and right, we're going to have something like this. So now the directrix is on the left-hand side, so the parabola faces right. So this will be x equals minus p. This will be p greater than 0. Okay, so now it's on the negative x side, so p greater than 0. Okay, and you can guess the last one. It's going to be like this. Okay, with the directrix on the other side. So this will be p being less than 0. Okay. Again, you just need to swap it in your head, given the p value. Okay, so again, for the vertical, that will be x squared equals 4 times p times y. And again, if p is positive or negative, that will be up or down. And then for the horizontal, that will be y squared equals 4px. Right, you just swap x and y. And again, depending if p is positive or negative, it will be left or right. All right. Any questions about this? Yeah, it's a lot to remember, but you chose engineering. You signed up for this. Okay, last one, the hyperbola. So I'll just give you the definition like we started with for the other two. All of the in-between algebra, that is left to you. Yeah. But it's the same as what we did previously. So lastly, number 3, the hyperbola. Okay, so how do we define the hyperbola? Okay, very similar to before. We have x and y. It's a little bit different because this one has asymptotes. You know, like one of x has the asymptotes. So we're going to have 2 asymptote lines. Like that. All right, you know your dotted line for asymptotes. And the hyperbola is drawn in between these like this. Something like that. Okay. Okay, so how's this defined? We're going to have two focal points, very similar to the ellipse. So F1 on the left, F2 on the right. So F1, this will be at minus C0, and F2, this will be at C0. Okay, so those are given. You're given the two focal points. Then what we need is point P on the hyperbola, so Pxy. We're going to have a line from F1 to P and from P to F2. So same sort of thing as the ellipse. So F1 to P and then P to F2. Okay. Okay, so how do we define it? So we define the hyperbola as the set of points P, exactly like we had before, such that the difference, please underline that, this is the major difference between the ellipse and the hyperbola. So for the ellipse, it was the sum of those two lengths. For the hyperbola, it is the difference between the two lengths. It is the difference between F1P and F2P. So the difference between them is a constant. Okay, so we have something like that. So I'll write out that first line just from this definition. Then you fill in the distance formula. You do the squaring on both sides, and then you'll get your answer. So here we have F1P minus F2P is equal to plus or minus 2a. So the plus or minus is there because F1P could be larger or F2P could be larger. So we don't know which one's bigger, so plus or minus. Okay, so for homework, do the rest, and you should end up with x squared over a squared minus y squared over b squared is equal to 1. And here we have c squared is equal to a squared plus b squared. Again, very similar but different to the ellipse. So here if we go back to the ellipse, b squared was a squared minus c squared. Here it is a squared plus b squared. You need to know the difference. And then just put a box around that. Okay. Yes. Yes. It's whatever points on the graph. You pick a point on the graph, you call it P. Okay. Yes. Yep. Okay. Okay, so please make sure you do this homework before Thursday. Otherwise, you are going to be very lost for that work. Okay. Any other questions? Okay. Okay. Where's the register? Register. Okay, it's in the front here. Please come and sign it if you need to.